All right, this is section 10.5, equations of lines. So we learned about slope in 10.4. We learned how to graph equations in 10.3 and 10.2. We learned how to plot points in 10.1. So essentially, we're going to take everything that we learned and learn how to graph equations with different methods, as well as creating equations based off of the algebra given to us. So for this section, I'll be using a little bit of the textbook to illustrate how to graph a line really quick. And we'll do, I'll actually pull up some examples from the book to kind of go over them. So let's look at this first off. Objective A. Use a slope intercept form to graph the equation. So right here, we're going to go ahead and graph this particular equation on this graph. Now notice it's in slope-intercept form. It's y equals mx plus b format. Remember, if it's in that y equals mx plus b format, we can actually graph it a little quicker. Remember, our b right here represents our y-intercept. So what we can do is we can actually plot on the y-axis -2. So over here on this graph, they plotted -2. Then what we can do is, remember, this is our slope, 3/5. Remember, the +3 means rise, the 5 means run. So if we recall our equation for our slope, remember it's m equals rise over run. So for this example, it's 3/5. So from this point right here, that 2, we will be going up 3 units, which would be right here, and then we'll be going, or I'm sorry, we'll be going up 3 units, then to the right 5 units after that, from that point. So if we look at this equation, and clear all that out, you can see right here they start at -2 and they go up 3. 1, 2, 3. That's where the up 3 units comes from. And then they go over 5 units. 1, 2, 3, 4, 5 units. And as long as you have 2 points, you can connect the line. So I'm going to demonstrate this one right here on paper. We're going to do this one by paper. Let's go over to my other app. This is example 1. Once it's a graph, y equals 2/3x minus 5. So looking at this equation, we have it in the form of y equals mx plus b already. Actually, to change the page settings, we're going to change it to our graphing paper. Let's do the 4 square inch. And there we go. So y equals mx plus b. Here we can see our m is 2/3 and our y-intercept is at 0, -5. So remember, this is -5 right there. Since we have a slope and a y-intercept, we don't have to make a t-chart like this, like we used to, and then we would choose a point and see what we'd get. We'd choose another point and see what we'd get. We actually don't need to do that. You can do that if you'd like to. But if you have your slope and your y-intercept, this is the easiest way to graph equations. So first off, I'm going to draw up my graph. I'm just going to make it like this large and this large. It doesn't have to be that proportional. I'm going to go ahead and use all the little tick marks that are already there as my points. Just going to draw my little arrows on the ends to show that the graph is going on forever. So let's look at this. We want to graph 0, -5. 0, -5 would be 1, 2, 3, 4, 5. 0, -5 is right there. That's our 0, -5 point. Now our slope, remember, it means rise over run. So we're going to go up 2, and then we're going to go right 3, according to that slope right here, from our point. So we're going to go up 2 units. I'm going to kind of do this in a different color so you can see it. We're going to go up 2, 1, 2, and then over 3 from that point. So from this point, 1, 2, 3. So you can see from this point we went 1, 2 units up, and then we go 1, 2, 3 units to the right. So on that point, we'll go ahead and draw our second point. And remember, we only need 2 points to make a line. So let's go ahead and connect those bad boys. And go ahead and connect them. And you want to use a straight edge, of course. I'm using the computer method. And there you go. You got yourself a line segment. So example 1, it was already in y equals mx plus b form, and we did the line really quickly. All we needed was 2 points to graph the line. Now, let's take another example. Example 2 from the book. This one happens to read, wants us to graph 4x plus y equals 1. Now notice this one is not in the form of y equals mx plus b. We have to get it to that form if we want to do that shortcut. So our goal is to solve for that y right there. So again, to solve for y, we did this earlier. We're going to have to minus the 4x on both sides. So that ends up giving us y equals negative 4x plus 1. Now you can see that it's in y equals mx plus b format. Once it's in y equals mx plus b format, you can see that the slope is negative 4. Our y-intercept is 0, 1. Once you have those two bits of information, we can go ahead and graph the line. I'm going to draw my graph again. There we go. And I'm going to put my little arrows on the end. It's the way it goes on forever. Let's do our y-intercept first. Our y-intercept is 0, 1. So it goes right there. Our slope is negative 4. Now remember, if it's a whole number like that, we assume that the number 1 is underneath it. So this would be negative 4 over 1. This would be our rise over our run. Now in this case, since we have a negative right here, our rise, we can kind of like put in quotes, would mean that it's not going to actually rise. Rise means it goes up or down. So rise in this case would mean down. So we're going to say it's going to go down 4, and then it's going to go over 1 to the right side. So from this point, we're going to go down 4, 1, 2, 3, 4, and then we're going to go over 1. There's our other point. Notice when we connect the line segment's going downward, and that makes sense because we learned that negative slopes make lines that go downward. There we go. And there's our line. All you need are those 2 bits of information. So every time when you want to solve these equations, all you got to do is solve for the y, and you want to graph it with the y equals mx plus b format. Makes it the easiest way to do it. Again, feel free to make a t-chart, whatever you want to. If given on an exam it just says graph the equation, you can use your t-chart method, you can use your intercept method, which you learned in 10.3, or you can use this y equals mx plus b format. Either way works. So you basically have 3 different ways of graphing the equations. So that brings us over to our next thing, where we're going to be talking about how do we make this equation right here? How do we start off and make that equation based off of information that we're given? Let's look at example 3 from the book. It wants us to find an equation, and it says with a y-intercept of 0, negative 3, and slope of 1 over 4. That's the information it gives us. So I like to write down all the information that's given to us without all the sentence structure. So we have y-intercept is 0, negative 3, and we have our slope is 1 over 4. We want to create an equation Now, it doesn't specify what kind of equation. It wants us to find an equation of a line. Everything that we've been working with are equations of lines. As long as it has a y and x, it's an equation of a line. Now, we're going to go ahead and try and put it in the format of y equals mx plus b. Remember, this is our slope intercept form. We essentially want to find an equation of a line, but we want to put it in this format right here. It wants to be in the y equals mx plus b format. So we need to analyze what we're given. Well, we're given a y-intercept. This is our y-intercept. And we're given a slope. Hey, this is called slope-intercept form, so we could actually plug in our information directly into the equation, and that would give us an equation of a line. So that would then result in y equals m is 1 over 4, x. Our y-intercept is -3, so we put -3. As you can see, this went right here, and this went right there. This is our answer. We have the equation of a line. Remember, equation means as long as it has an equal sign. In slope-intercept form. You can see it's in y equals mx plus b format. So we're done. So that gives us the equation of a line in that format with that information. Now, not all of them are essentially that easy to where we can just plug in the two bits of information. So what we want to do is, for example, 4, they give us some other information. It says find an equation. I'm going to paraphrase or abbreviate. Find an equation with slope. I'm going to go ahead and write m equals -2. It says with a slope. So I'm going to write m equals -2. And it says that passes through -1, 5. So once it's to find the equation of line, last time it gave us a slope and a y-intercept. This time it gives us a point. That's just a random point. It's not the y-intercept, so we can't really use our shortcut. Go ahead and get this to fit. It wants us to find the equation. It wants us to write it in y equals mx plus b form. And it also wants to do us to do it in ax plus by equals c form. I'll explain what this is in a second. So first off, we want to put it in y equals mx plus b form or this form. Both are different. Both are linear equations. It's just a different way that we write them. This one is called slope-intercept form. We've been over that. This one right here is sometimes called our standard form. Some people might call it general form, but it's also called standard form. Go ahead and erase these little words, and we can go ahead and move those up. So that's our different types of equations, slope-intercept form and standard form, different ways of writing the equations. Personally, I find this way more helpful, but some people don't like writing it in that form, so we write it in this form. Each one has a different way of doing things. And you'll learn that in college algebra. You're going to write things in something called parabolic form or vertex form, and then some in general form. You'll have different ways of writing the equations. So first off, this brings us to another useful equation that we have. This is called, this one's called slope-intercept form. This is standard form. This one is called y minus y1 equals m times x minus x1. It's called point slope form. Now looking at this, it's called point slope form because if you remember, x1 and y1 will represent a point. M right here is your slope, hence point slope form. So what we're going to do is, because we are given a slope of -2 and a point of -1, 5, I'm going to use this equation right here to find the information. So let's take it. I'm going to go ahead and write it down. y minus y1 equals m times x minus x1. Remember, this will be our, I'm going to do the red. This is our x1, this is our y1, and the m is our slope. We're going to substitute those values in. So this gives us y1 is 5, so it becomes minus 5, equals negative 2 times x minus negative 1. So I plugged in the negative 1 right there, in for the x1, and the 5 in for y1. We want to start simplifying. I find it easier to get it into this form first, and then we'll put it into standard form afterwards. So let's work on putting in slope-intercept form. To do that, let's start simplifying. Remember, a negative times a negative, right here, negative times the negative becomes a positive. Y minus 5 equals negative 2 times x plus 1. Let's then go ahead and distribute that negative 2 to both of those numbers. Y minus 5 equals negative 2x minus 2. Remember, to get it in this form, the y equals mx plus b form, we need to get y by itself. So to get this y by itself, we need to add the 5, get rid of the 5. So add 5, add 5. Now we have y equals negative 2x plus 3. And as you can see, it's in y equals mx plus b form. So this would be one of our answers. We have it in slope-intercept form. Now it wants us to also do it in standard form. So what we can do is take this equation right here that we have boxed in the red and start working on it. I'm going to go ahead and rewrite that equation up here. Y equals negative 2x plus 3. I didn't change anything. So according to standard form, right here for standard form, go ahead and swap these out. Or rewrite them. So for standard form, there's some rules. First, A, B, and C need to be whole numbers. They need to be whole, or not whole numbers, rather, they need to be integers because they can be negative. So A, B, and C need to be integers, meaning they cannot be fractions, they cannot be decimals. And that's the main rule. Some books, some textbooks, have also the rule that A needs to be positive, needs to be greater than 0, or I can put it in non-math terms, A is positive. So A has to be positive. So what we're going to do is we're going to manipulate this equation right here to fit that. According to the standard form equation, notice it has x and y on the left side of the equation. Here we currently only have y on the left side of the equation. The c in this case is just going to be a number. So our goal to get this into standard form is to have x and y on the left side of the equation. So currently we have y. We need to move the x over to the left side. So to move it to the left side, we need to go ahead and add 2x on both sides. That then gives us 2x plus y is equal to 3. And that gives us our answer. We can see that 2 is an integer, 1 is an integer, and 3 is an integer. So it meets this criteria. It meets that one. And A is positive, meaning the front number right there is positive. So there is our final answer for it being in standard form. All right, so transforming it into the slope-intercept, then the standard form is usually easier than the other way around. Let me pull up an example from the textbook so we can kind of go over this one more time. Just want to do an example. I'm going to do, going through the book. Let's go ahead and write an equation of a line in both forms. Let's do number 24 from the book. It gives us the information m is equal to 4, and it gives us the point 1 comma 3. Let's put it in y equals mx plus b form, and let's also put it in ax plus by equals c form. And remember, a, b, and c are integers, and then a is positive. So we're going to put it in y equals mx plus b form first, then ax plus by equals c. So we're given a point and a slope. So let's go ahead and use our point slope form again. We're going to use our point slope form equation. Go ahead and write it down. Again, our x1 is right here, our y1 is right there, and our slope is 4. Substitute all the values. Y minus, not minus 4, y minus 3 equals 4 times x minus 1. Go ahead and start solving for y, and in order to do that, we have to distribute first. Y minus 3 equals 4x minus 4. Then, to solve for y, go ahead and add 3 on both sides. Now we have y equals 4x minus 1. And there you have it. So here we have it in slope-intercept form. That's part of the answer. So this is done. That part's done. Let's get into ax plus by equals c form. So remember, in order to have it in that form, we need the x and the y both on the left side of the equation. So we have to subtract the 4x. Minus 4x minus 4x. Remember, you can't put the x and the y together. So I'm going to write negative 4x plus y is equal to negative 1. Now we have a, b, and c are all integers, meaning we have negative 4, 1, and negative 1. So they're all integers. So what we're going to do now is make sure a is positive. And as you can see, a right here is not positive. So in order to make it positive, we need to change the sign of it. And to change the sign of any number, we can just multiply it by negative 1. So we're going to multiply everything on the left side and everything on the right side by negative 1. Because remember, what we do to one side, we have to do to the other. This then changes it to 4x minus y equals 1. It now makes a positive. That's our final answer for that. So put it in the standard form isn't too bad currently. There's some other problems that get a little bit more difficult, but you're not going to be tested on those. But changing the form of an equation is important because you're going to be doing that in your college algebra course a lot. You're going to be manipulating equations. So let's try making another type of equation. It wants us to find the equation of vertical and horizontal lines. So I'm going to look at this one. This is example 6. It says find equation of a vertical line through negative 1 comma 5. So this time it wants us to find the equation of a line, but it's a vertical line. That's the key thing. If we remember correctly, vertical lines are either y equals or x equals. Vertical lines are always x equal equation. Remember, x equals c represents a vertical line. We learned that way back in the day. And by back in the day, about 2-3 sections ago. So x equals c would be the vertical line. In order to find this equation, all we have to do is look for the x coordinate that goes right there for the c. So our x coordinate is negative 1. So that then means our equation is x equals negative 1. That's your equation of a vertical line. Hypothetically, let's say it said find an equation abbreviate, of a horizontal line through the same point. Say it was the same point, -1, 5. Remember, horizontal lines are y equals c. That would be a horizontal line. So in this instance, we want to find the y-coordinate, which is 5, and that's going to go for the c. So your equation would then be y equals 5, be your answer. So if you're looking for horizontal lines, you want to have y equals. If you're looking for a vertical line, you want x equals. So notice the difference in what the instructions are doing. Notice it's the same point, -1, 5, -1, 5. Same point, different types of lines I want you to find. Vertical lines, you look for the x-coordinate. Horizontal lines, you look for the y-coordinate. Now, there's some tricky questions right here. For example, 7 says find the equation of a line parallel, keyword parallel, to the line y equals 5 and passing through the point -2, -3. So if we look at this, it's asking for another line, but it's parallel to this current line. So let's kind of graph this idea really quick. This is going to be a quick graph. Not do anything fancy. Let's look at y equals 5. I'm going to go ahead and graph that with the blue. Y equals 5. Remember, y equals 5 would be a horizontal line. So it's 1, 2, 3, 4, 5 right here. And it's going to go right there. So remember, parallel means it'll never intersect with it. So I need to have a line that's going to go kind of like this, anywhere like this. Lines that run parallel to it. It's a matter of where do I put it. Am I going to put the line somewhere like here? Is it going to go here? Is it going to go here? Is it going to go here? We need to find the other line that's parallel through it, but also goes through this point. So let's look at that point, -2, -3. -2, -3 is -2, -3 is right there. So if I want the line to be parallel to the blue line, it has to go like that. And then we need to learn the equation of a line. Remember, horizontal lines like we have over here, horizontal lines are always y equals c. So going over here, horizontal line, the y-coordinate for this point is -3. So the equation is y equals -3. So what we just did is we found a line parallel to y equals 5. But not only that, it goes through this point. Remember, there's an infinite amount of lines that could go here and here and here that would be parallel, but it wanted it through this specific point. So that'd be the answer. If, hypothetically, let's change it up a little bit. What if it was the same thing? Find one that's parallel, but it's to the line x equals -3, and we'll say through -2, -3 again. Well, let's go ahead and draw out a little graph here. Parallel to x equals -3. I'll do this one in blue. X equals -3 is a vertical line. 1, 2, 3 at -3. So in order for it to be parallel, the new line has to be going like this. And it needs to go through -2, -3. So -2, -3 is right here again. Now, in order to make it parallel, we would have to draw it right next to it. And you look at the x-coordinate. So your new equation would be x equals negative 2. That would be your answer. So notice the difference between them. Notice if it says parallel, our line given to us is going to have the same variable if they're parallel. Parallel means same variable. Parallel means same variable. So y to y, x to x. But you might have a different problem on your homework. Let's do another quick example. Say, find equation of line perpendicular to, we'll say y equals 1 through the point negative 1 comma 2. So let's look at this. Let's go ahead and draw out our graph. Gonna move this over a little bit. A little bit more room. All right. So let's go ahead and draw y equals negative 1 first. Y equals negative 1 again is a horizontal line through 1. Now remember, perpendicular means it has to run at a t or a right angle. So the next line has to be like this, somewhere like this, to where it creates those right angles. It's a matter of where we put it. It says negative 1 comma 2. So negative 1 comma 2 is right there. So to draw a line perpendicular to that, we go to this dot and we need to draw it the opposite direction. We go vertical. Since it's a vertical line, we have to look at the x coordinate for it. So that would mean this red line would be x equals negative 1. That would be our answer for this one. So to find perpendicular, notice the variables will be different. Y and x, they'll be the opposite. Whereas for parallel, they'll be the same. Y and y, x and x. So that'd be the difference between the two. And those are a little tricky. You're not going to have a lot of questions like that. Maybe like one on the test like that. I know on your homework it has one of them. But know the difference. So perpendicular, they need to look different. They need to make a T intersection. For the other one, they need to look the same in terms of running parallel to each other. So parallel mean never intersect, perpendicular intersecting at a T intersection. Okay, that brings you to the end of 10.5 and Chapter 10. So Chapter 10 covers graphing. You won't see graphing again for the rest of this course. And the next course, 0 through 20, or your co-requisite to college algebra. You might do a little graphing with systems of equations, but definitely in college algebra, you will be graphing a lot more. And you'll be graphing different types of equations like parabolas and logarithms, all this other fun stuff. But you're at the end of this one. After this, we'll go into Chapter 12, which is learning about polynomial expressions and what to do with them. So go ahead and study up for Chapter 10. Look at the exam. You have some chances of taking the exam. And always practice the boot camp, because that'll help prepare you for the exam.